For question 2, it asks, draw a graph comparing an untrained and trained person's insulin response to steady-state exercise. Explain why this training adaptation occurs and why it is beneficial for exercise. So in this graph that I drew, on the x-axis I have the time in minutes for a steady-state exercise that lasted 60 minutes at the same pace or intensity, and then on the y-axis I have the insulin percent change, and these values are negative because as we exercise, we are inhibiting or releasing less and less insulin because we want to promote the breakdown of fuels, and insulin promotes the storage of fuels, which we want to break down our fuels in order to fuel our working muscles. And so comparing a trained to an untrained individual, we see that a trained individual inhibits insulin slightly less or releases slightly more insulin than an untrained individual. This occurs because a trained individual is going to release less and less epinephrine and norepinephrine compared to an untrained individual. This is because the trained individual's body becomes efficient and it's used to the demand and stress being placed on it, and therefore insulin is inhibited slightly less in a trained individual compared to an untrained individual. I have flow charts for each just to kind of visualize what I'm going to be talking through. So for an untrained individual, like I was saying, they're going to release normal levels of, or higher levels of epinephrine and norepinephrine, and then epinephrine and norepinephrine are going to send signals to the pancreas to then which will then inhibit the release of insulin. This means that less and less insulin is going to be released, and therefore that leads to more fuel breakdown and less fuel storage. Because again, insulin promotes the storage of fuels while glucagon promotes the breakdown of fuels. And since insulin is inhibited in this case, then glucagon is going to be stimulated or released more in order to promote this higher fuel breakdown than fuel storage. Sorry. So now for a trained individual, like I was saying earlier, there is less epinephrine and norepinephrine being released, and so this sends less signals to the pancreas, which therefore is going to inhibit the release of insulin slightly less. And because of this, that means that there's going to be a little bit of insulin released, and therefore that means that there's going to be a little less fuel breakdown and a little more fuel storage. In addition to there being less epinephrine and norepinephrine in trained individuals, this means that their body is able to use more fat cells in the beginning of the workout in order to fuel muscle contractions, and that ties into the crossover effect where at lower intensities we are utilizing fats, and then we hit an intensity in which we use carbs. And in this case, for steady state exercise, we are probably working out for a long duration of time at a lower or moderate intensity, so our body is able to use fat cells for longer. And this also is why we are able to store a little bit more of our fuel or our carbohydrates or glucose, because when we're able to utilize fats, we can then store and save our carbs for when we need to use them. And so that is another aspect that plays into this less epinephrine and norepinephrine. So overall, a trained individual is going to inhibit the release of insulin slightly less, meaning that's going to release insulin just a little bit more to promote slightly more fuel breakdown, which leads to less fuel storage, and then we have a little less fuel breakdown, and and then in an untrained individual, we're going to inhibit insulin release more because we have more epinephrine and norepinephrine, and therefore we are going to break down fuels more and store less. And trained individuals being able to break down less and store a little bit more, we are being very efficient with our fuel source, and we're able to efficiently utilize our fuel source better than an untrained individual.